Welcome to Pavithra Laptop Care. So today's topic is addition. Addition is very simple, right? For example, 1 plus 1 is equal to 2. Everyone knows, right? See, this is in decimal numbering systems. Okay, what about system? How a processor works, that I am going to tell you today. See, 1 plus 1 in binary, it will be 1 0. 1 0 is binary numbering system. Okay, see, 1 plus 1 is 2, but 1 carry will be there. In binary, maximum number is 0 and 1, right? So second digit will be 1 and 1 carry it will come. Okay, it means we can't pronunciate it's 2, so that's why 0 will put and 1 carry we will take. Okay, see, this is very simple. But this simple process, how it will be in processor? Any guess? Okay, I will explain. In previous video, I already done logic gates. Logic gates. What are those? One is AND, OR, NOT, XOR, XNOR. Okay, these are the major logic gates. One thing I already explained you, processor can understand only machine language. Those are zeros and ones. Okay, it contains million or billion number of transistors or logic gates. Okay, a simple example I will show you how a processor will add these two. 1 plus 1 is equal to 2. Okay, see, first this decimal number will be converted to binary, means machine language. Then this machine language a processor will get through register and then it will start working through the logic gates. Okay, see, in one logic gate, 1 plus 1 is equal to 1 0, means 2 output should come. Okay, here it's a 1 output and here is the other output, and here the other input 1 plus 1 is equal to 2 output, one for carry and one for normal one. Okay, see, this one and this one, we'll consider it as A and this one is B, is equal to Y is the answer. Y and Z. Okay, these are the output. Now AND gate. What is the formula? 0 0. If A and B is equal to A 0 and B 0, in that case result will be 0, right? So if it is 1 and B is 0, then it will be 0. Okay, and here 0 and 1 will be 0. 1 1, both inputs are equal, means high, then the result will be 1, right? This is the AND gate. Second one is XOR. You know the OR gate, but XOR also I already explained. XOR logic gate is 0 0. If both inputs are 0, then output will be 0. Okay. If one input A is high and B is low, then output will be high. Okay. This one A will be 0 and B will be 1, then output will be 1. Okay. Next, if A is high and B is high, in XOR gate it will be 0 because one carry over will be there. Okay, that is the specialty of XOR. In only OR case, 1 1 will be one output. Okay, so you know why I am telling this. Before doing some logic gates works, first we need to understand what are the input and what are the outputs of particular logic gates. See, again I'll come from the beginning. See, 1 plus 1 is equal to 2 in decimal, 1 plus 1 is equal to 1 0 in binary. But processor can understand only this one, it will understand through the logic gates. So that's the reason I am explaining these two, because I am going to make a logic gates. Okay, see, one is XOR. This is XOR gate. This is A and this is B. This Y output. Okay. So logic I already told you. Now the input. Now what we are doing, 1 plus 1 we are adding. Means A will be 1 and B will be 1. Then output will be 0. Okay. That's called Y. 0. Output Y is equal to 0. Next, for this I already explained one more logic gate, that is AND gate. This is Z. Okay. This one is B. See, in this condition, A is 1, I attached AND gate to XOR gate. A is 1, B is 1. Then what will be the output? Z is equal to 1. Okay. This one we will write it as a 0 and 1. Okay, this is a carry. This is called addition of logic gates. Okay. Like this, I already told you million billion of logic gates will function. This is only one basic example. Okay, today's classes, that's it. So in future, in coming classes, advanced level you can learn it. Thank you very much.